So my talk today is about augmenting human mind by artificial intelligence, and it's a kind of bunch of different aspects which are important to look at nowadays. Before coming to my entire topic of the talk, I'd like to give you a short introduction to DFKI, since Professor Jin King asked me about doing so. I'm sure all of you know Google, but maybe not all of you know about DFKI. So DFKI was founded in 1988. It has its location in, this is the headquarters, Kaiserslautern, where I come from. It's southwest of Frankfurt. And it's now available at different sites. So beside Kaiserslautern, there is a Saarbrücken site, which is about 60 kilometers west of Kaiserslautern. And from 2005, we have one more site in Bremen, and our government wants us to be in Berlin, so we have an office in Berlin and a small lab in Osnabrück in west of Germany. I don't go into the details. If you like to know more, you can also visit the website. DFKI is a very special organization, since it is a non-for-profit research company directed by university professors. And as it is a company, it also has owners. And these owners are shown here, so you can see beside the universities I already mentioned, you can see small and middle-sized companies, but you can also see world leaders. So over time, the shareholder number grew up to now 23 in total. And as you can see, it's not only limited anymore to German shareholders, but also to international big players like Google, for example, but also you can see Intel or Microsoft, John Deere, the Japanese company Ricoh, and so on. So it's open, it's a global acting community, acting for many customers. It grew up to the world's largest AI institute with about 440 full-time researchers, and beside the master and bachelor thesis, many students also work on an hourly basis for DFKI within the various projects. It's a total budget of about 42 million euro per year, and many, many ongoing projects. So this is a selection of customers beside the shareholders I mentioned. We are not only working for the shareholders, but working for institutions like United Nations, big insurance companies, Motorola, Apple, Hewlett-Packard, and so on, including also Japanese and other major companies from all over the world. DFKI is characterized by having a very international staff. So this is a very important fact, that we are looking for staff which also complements the various insights into solutions for problems. So cultural background, education is a very important aspect. So as you can see, more than 50 countries are there, and many of the employees at DFKI have a temporal contract. So when they join DFKI, we start discussing with them, what is your life goal? And to get a better idea about whether they like to join a company or go to academia or found a startup. So it's important, because at the end, what we provide and what we generate is a network of friendship, since we have more than 2,500 alumni. And these alumni nowadays have professorships, they're working for major companies, they run their own business. And so it's important, if we propose new projects, to have such a network to build on. There are a couple of numbers, also just to show you some short figures. DFKI staff, former staff, now are 85 professors. And I told you about collaboration with industry, and in many cases we not only do solutions for industry, but rather also have very ripe technologies to found startups. So one of our mission is also transfer regarding startups, and we already produced more than 60 startups with many jobs outside DFKI, for which we received also many years ago the German Spin-off Award. So this is DFKI in a short. Maybe later on you might have some questions regarding this. but because time is running, I like to stress a bit more my main part. This is about augmenting human mind. And I put together 3 examples today to give you insights into different aspects of how to augment human mind. And I'd like to start with a statement which is made by Daniel Dennett. He's an Erasmus Prize winner, and he talked about all varieties of perception. Indeed, all varieties of thoughts or mental activities are accomplished in the brain by parallel, multi-track processes of interpretation and elaboration of sensory inputs. So what's going on is that information which is entering our brain is permanently under editorial review. So if you look at our brain, it's composed of 2 major dimensions. This is the rational dimension and also the emotional dimension. So on the rational side, we have different aspects like learning, understanding, memorizing or reasoning. And on the emotional side, there are aspects like loving, hating, and enjoying, hating. And these aspects always work together in order to finally also select things, to weight aspects, ideas, to reject them, to complement what we have in mind, how to change our mind, how to keep track of what's going on. And this is the secrets or the basis for perception, for our thoughts, for our opinion, whatever is there. And as output, we are able finally to do many cognitive aspects, like an analysis, like the correction of things, like generalization of problems, about synthesis of things, comparison, so many aspects. But it's not only our individual mind, it's also the collective mind, which is of importance, specifically if we talk about business impact. And as I told you, DFKI is always looking at problems. Everything we do is based on projects. We are running projects, and at the end we have something to deliver. And let me start with a picture that I recently saw. It's published by Microsoft, and it announces the so-called Microsoft Graph. And this is maybe similar to what Google has in the background of his recent search. This is the knowledge graph, and it addresses the option that we have a multitude of information sources, and we have to maintain them, we have to manage them, to coordinate them somehow. And within all these different sources, independent of an application, there are relationships. And if you look at such a graph, it's very similar maybe to what we might have in our mental models, that we have persons who attend an event, who have a certain mindset together in a certain calendar entry, and so on. And this is maybe the basis to talk about. Also, this is recently published. DFKI developed many years ago a method to keep you up to date in the complex or the ever-growing complex world. And this is about augmenting human mind by helping all the different knowledge workers to remember. So people like you and me, who have to deal with multitasking craziness every day. So, and this is about the semantic desktop. So on my slides you will also find many references to papers where you can have more deeper insights into the various technologies. I think they are available via the website. So let me talk about the semantic desktop. What is it? So if you look at a typical knowledge worker like this guy, his name is Heiko. He is not real, but virtual, but he is, as you as me, tackling many tasks, and right now he has to organize a visit of another virtual person named Professor Tanigali on March 28th. So what Heiko is usually doing is that he enters the visit date in the calendar system. Maybe he is using a task management system to enter the task for the invitation. He has to prepare an agenda, maybe also maintain the contact data, Further on, he has to write an invitation email to Professor Tanigali and finally attach the agenda to it. So what happens if you look at this image is that you have various pieces of information, emails, office documents, address data, calendar entries, tasks, and so on. But they are all living or resident in a parallel world. Yeah? They all are bundled together in the head of Heiko. Yeah? He is the main hub where all these aspects of information come together. Yeah? And if you look at Heiko's desktop, he has to maintain maybe 600 different folders and different applications with several thousands of files. And he is the interface to all these thoughts. All of them are thoughts which are related to events, to persons, to projects, and whatever. So what happens right now is that we have different worlds. Such an email, for example, is part of an email system and is put into a folder, while the attachment is part on the directory system in the file system. Beside that, maybe he is managing contacts in another application. He has bookmarks, he has an index system. So many different things are in parallel and it's hard to get track. So the idea is to use semantics, and they go back to the semantic web. Have you heard about the semantic web? It's the idea of Tim Berners-Lee to introduce the web of meaning. But to get a unique meaning worldwide, it's too hard. We have different attitudes, different cultures. Even from language to translate, it's very hard. So you can't find a unique meaning. But if you start from an evolutionary way, from the entire desktop, from the memory of a human being, it's much easier to handle. And therefore, we built on these World Wide Web standards. They are the web of meaning, in order to represent the meaning by very simple ways. So the objects are semantically interconnected, as I showed you, through the brain of Heiko on one hand side. On the other side, we use RDF. This is the Resource Description Framework. This is one important standard of the World Wide Web Consortium to represent meaning. And this meaning is just represented by simple phrases: subject, predicate, object. Simple sentences called triples. And there's an example that Heiko works for DFKI. So we have subject, predicate, object relationship. Yeah, in order to know which Heiko this is, because Heiko is a very common German first name, yeah, you are making use of URIs. Yeah, because URIs are very unique. They have namespace and they are unique in the entire web. And based on what Heiko is, we can also introduce what we always do. We introduce categories, like folders, about projects, organizations, about products, whatever we need in this context. So as a result, what happens is that we have such an agenda I showed you at the beginning, and this agenda has a unique ID. A URI, it's somewhere in our directory system. And this is related to an event, to a category. Subject, predicate, object. Furthermore, this is taking place at a specific location. We can make use, oh, it's not so nice to see. Could you change this a bit? It's not sharp. But anyway, you can guess. It's another URI, and this is from Google Maps. Yeah? Every URI is subject, predicate, object. And this is a location. Yeah? So you can proceed. There is a person who is participating in this event, and another one, and they both are persons. One person is working for DFKI, while the other person is working for the university in Portobello, and they are both organizations. You can further think about addresses as in Outlook. addresses have URIs, calendar entries have URIs, subject, predicate, object. What we receive at the end is a network. And this network is very similar to our thoughts, to our associations, combining resources independent of the application together to something we can remember. And this is represented in a computer-readable and understandable standard, RDF. So at the end, we have a personal information model at Heiko's workspace. And Heiko can work with this information model. So to show you, let's go back to July 29th, 2014. And Heiko is a knowledge worker, so he has many tasks, as you can imagine. He is also a project leader of a project which is called Forget It. It's a real project at DFKI is about forgetting in internet. And Heiko is planning a workshop in Istanbul in Turkey the next day. So he's going to prepare the workshop by writing down some notes. And while writing down some notes, the personal information memory is continuously watching at him and helping to do things. And this was part of the so-called linked open data cloud. This was implementation or the realization of the semantic web announced by Tim Berners-Lee, researchers started to generate RDF triple stores, big ontological knowledge. There's, for example, DBpedia. This is the RDF version of Wikipedia. So there is also a RDF semantic representation of Wikipedia. And this was at the beginning, and you can see this linked open data cloud grew up. The US census information is nowadays available as RDF. UK and Sweden publish every information relevant for their citizens as RDF, machine readable information. Any machine of the world could read and understand this type of standard. So what's possible is that user-generated content in these personal information models could be connected to the linked open data cloud because it's the same representation. So it's very valuable, not only for Google, for many organizations to make use of this open data. It's also important, but let me come to my second aspect, talking about augmenting human mind by identifying the relevancy of information. And it's about attention recognition. Attention is a very important part of human communication. If I look into your faces, I can see whether you are attentive or not. Whether my talk might be interesting to you or not. So anyway, attention is very important. Again, references over here. So you can look in people's face. You can see that not only people, also animals are attentive. So attention plays a very important role because most of the information we learn is coming through our visual senses. And it's captured in our brain back. So what happens is, then if we have information, we are perceiving the information and then establish a shared concept, a context, via transformation of all meaningful parts which we weighted, selected, filtered, we use blinders, and then try to capture the knowledge in our brain. If we do that, it very much depends on various aspects about the data quality, about whether you have time, whether you are interested in what is your intention, about the ability also knowing about the contents of something. So many things are important. But let me start with some basics in here. So if you watch me on the stage over here, you usually have a 180-degree image, but your focus of attention is given by your eyes. So you focus on something, and on what you focus is currently part of your thoughts, your imaginations, your associations. Yeah? You have also this blind spot somewhere. Yeah? Furthermore, also you have muscles at the eyes, and these muscles do a horizontal, vertical movement of your eyes continuously, and you usually have the options to fixate something. Yeah? And if you move your eyes, you can't see anything until you stop again for the next fixation. So you have a saccadic blindness. Yeah? No option to perceive information. But anyway, through our perception systems, everything is done with saccades and fixations. And the idea we had in mind is to make use of eye trackers to monitor, to observe people and analyze the relevancy of contents to individuals. So we have wearable eye trackers nowadays, and they project some infrared light to the backside of your eye. This is reflected, and then we are able to capture the fixation points with an accuracy of less or better than 1 degree of visual angle. So the idea is then to analyze the visual path of people, which is important for applications like usability. But in our case, we are more interested in how people read, what people read, how deep people read. So if you look at reading, there are various ways to categorize reading. This is first of all regarding the purpose. If I force my students, you have to read this paper, it's different than sitting in the airplane and reading a book. The same holds also for the forms, whether it's oral or silent. There are various studies which also tell that if you're loudly reading, this would help you better to remember if you're under disturbed. But more interesting is the psychological process, where we have observatory reading to creative reading, from noting to employing information. And we were able, through our experiments for a single reader, to distinguish between these different types of reading. But since all readers are different, our idea was rather to develop something which is more robust, namely to distinguish between skimming, so information which is not that relevant. So people just try to get an orientation about contents. And the other idea is to really see what is relevant to people, what is carefully read, what is investigated and employed. So we developed a couple of techniques which transform the very noisy data from an eye tracker. Of course, here is no time dimension, but this is just to the point of regards. To find out fixations, this is shown, the diameter over here shows the time of fixation, and the saccades, also regression steps are given, and to map this information to the text, and then being able to finally also label the text with metadata. Namely that this text is read by a person named George at a specific time, so many characters, he needed so many times for reading, and there is a number of regression steps inside. So we can generate metadata based on that. As a consequence, we were able to improve a couple of things, namely search engines. If we are going to observe humans when they read information provided by search engines, we can improve the search results. I'll give you an example, maybe on this slide. If there is a user which would enter the German term for bird of prey into a search engine, he usually receives some results. If a human being would then look at a certain number of documents, we can use these documents to generate implicit relevance feedback. This is just by looking at the terms in the documents to extract them automatically and to use some statistical methods like TF-IDF to get insights into these documents are about eagle and habitats, yeah? And furthermore, if we complement it by scene, we have a new list of results, which are more relevant to the user, by just looking at those documents he looked at. Anymore, but we go further and not use the entire documents, but only those passages which are read. We can complement the information, yeah, and also the statistical evaluation by the interest, and then see that it's not the eagle habitat, but rather it's the eye and the retina, and we could again change the search results by just watching on the attention. And based on that, we received about 20% of improvement. It's also for classification. So assuming there is a journalist who is eager to write an article about Brexit, this is the outgoing of Britain from the EU, yeah, he usually is looking for some documents. Yeah, he's collecting about this topic, and these documents then are maybe put into a folder. Yeah. And similar to the idea I showed you before, this is done manually. And the classification is based on this very subjective perception of the human being, right? And for making her or his decision, respective categorization, the user normally reads some passages, skims over some others, and also ignores some more, according to the interest. So if we are going to make the document terminology in the folder available, and combine it with the reading data which we have, we can generate a kind of conceptual representation of this information inside, and therefore we're able to improve classification by 45%. But there is even more we can do with it, and therefore I'd like to address shortly a new technology called iBook with the E-Y-E. And this iBook is complementing contents of a book together with reading, with gaze information. Because of the lack of time, I skipped to the video to show you how this works.
The word you're looking at is pronounced China.
I should stop here, but I think you received the impression of what's possible if you use gaze data, attention, and provide attention or information on attention at the same time. I have to skip this. We can also work on paper with that, reading from paper, not only on the screen. Because time is running, I like to come to my third application. This is augmenting mind by understanding human emotion. And this is a pretty new field, so I'm very glad that Dave Silver gave you an introduction into convolutional networks, since this is one of the hot topics nowadays, because we would like to understand sentiments, visual sentiments in images. So why? Because, well, the relationships between the reality and the human being are manifold, and they could be expressed by the semiotic triangle. So everything what is around us, the reality, is shown and given through our eyes into our brain. This is about a soccer match. So, and the human being is able to capture the thoughts, maybe by taking pictures, and also label the pictures, like great match, or crazy fans, and later on, if the person looks at the pictures, or maybe someone else would look at the pictures, there are imaginations and emotions which are uploaded again just by looking at them. And this is a very important field to get insights into the emotional state of people. So if I would like to ask you, what do you see here? Can you give me an answer? Not so easy, right? Maybe if you would write it down, you will have different ways, but on Flickr, this is tagged with abandoned building. And the right one is tagged with stormy landscape. But what I want to say is that there is more than one description possible for pictures. Maybe some of you saw a bridge, or some misty parts somewhere, so it very much depends. It's also shown in this example here about social media. The New York Police Department just opened a channel where people can submit pictures and comment the pictures about a friendly policeman. As a result, they received pictures like this. And if we look at the pictures and the text sometimes captures sarcasm. So from the text itself, it's hard to understand. But in combination with the picture, you're able to understand the sentiment of the sender. Another aspect is also shown here. Nowadays we have crawlers, and the crawlers search the web for pictures, because if they find something like a dog, some companies are interested to place their advertisements. The problem only is that we have such dogs and such dogs. So maybe you don't want to place your advertisement with such a scary dog, but rather with a cute one. So what we need is, we need a deeper analysis of contents. And that's what we did based on data. So similar to AlphaGo, we used an approach which is built on 3 different aspects. Namely, on deep learning. The second aspect is that we not only use concepts which we know, like cat, dog, mouse, building, whatever, but we also use a sentiment ontology describing adjectives like bad, nice, beautiful, crazy, scary, whatever. So we use a visual sentiment ontology in combination with some findings from psychology, which is built on a bipolar emotion model. And this is the so-called Wheel of Emotions by Plutchik. He is trying to describe emotions by colors. And if we combine all these three aspects together, we can train our convolutional network by the largest data set which we have available nowadays. These are 100 million labeled pictures from Flickr. And 80 million of them have geodata. Many tags are available, so we know what users think about pictorial contents. And when we train our network is able, the convolutional network, to provide this type of result. So as you can see, this picture is a little church, ancient house, a damaged church, ancient bridge. This one is a stormy mountain, stormy coast, misty hills, and so on. The interesting aspect is nothing is wrong, but it shows the subjective way humans categorize information. But we were also interested in, this is open, so there are links to the available sources. You can check and go there on my website. And we also extended this deep Centibank with a full connected network. So we enhanced it in order to find inside the picture where is the stormy wave, where is the stormy coast, and where is the stormy cloud. So we partly localize emotions within pictures, like this is part of a clean car, here is the dirty car, this is the happiness of a baby, this is the cuteness of a baby. Yeah. There are some links here as well to Centibank, where we have a dream map representation. All the pictures we have are categorized into the emotions, like cold, like pretty, like dry. This is about misty, and this is about misty woods, and so on. And it's also available via adjective-noun pairs at the same time. So you have an alphabetic order of the various concepts. You can just navigate within those, and you can also use it via localized information. You can enter a city like Kaiserslautern, and you receive all comments from the many people. Thanks a lot.